Hey guys, Travis Gillespie here. In the last video, we were listing factors of a product. This time we're going to be given a value, so I want to erase some of this information. We're going to be asked to write the prime factorization, right? The prime factorization. Okay, so let's say we're given the value 42. And we could list all the factors here for 42, but we don't want every single number, it sounds like. It sounds like we want a specific set of numbers. We want the prime numbers only. What are all the prime numbers that can factor into 42? So what I've got to do here is break this number down. And I'm going to use something called a factor tree. I like factor trees. Now, some other books, and actually our textbook, will show you how to use the ladder method. If you want to try the ladder method, great. Check it out online or in the textbook and start using it. But I like the factor tree, and that's the one I'm going to show you how to do. So I'm going to ask myself, what numbers multiply together to make 42? Well, the numbers 6 and 7 will make 42. And then from there, I'm going to ask myself, well, what about 6? What about the number 6? What numbers multiply together to make the number 6? Well, the numbers 2 and 3. And then I'm going to ask myself, well, what numbers multiply together to make the number 7? Well, only 1 and 7 work out here. It must be a prime number, so I'm going to erase some of this information, and I'm just going to make a note that 7 is prime. And now I'm going to circle that value. Since 7's a prime number, I'll circle it in my factor tree. Let's go over to the numbers 2 and 3. The same thing happens. I can only divide 2 by 1 and itself. Therefore, 2 is a prime number. Also 3, the same thing happens. It's a prime number. So I'm going to circle 2 and 3. Notice I've circled all of the numbers that are prime in this factor tree. Now I'm going to list all of these circled values below, showing that 2 times 3 times 7. Now all of these numbers, they're all prime. 2, 3, and 7 are all prime numbers. And if I factor them together, well, 2 times 3, that gets me to 6. 6 times 7 will get me to 42. So this list below, since I'm showing that all the prime numbers multiplied together make 42 in this case, this list shows the prime factorization of 42. I can box up this final answer. And let's take a look at another problem. What about the number 36? And I'm going to use my factor tree. And I know that the values 6 times 6 will get me to 36. I want to change colors real quick. So here I know I can multiply the numbers 2 and 3 to get to 6. I'm going to change colors again. 2 times 3. 2 times 3 will get to 6. Again, the same thing over here. So we have 2 times 3. We'll get to 6. And I can't break these numbers up any further. They're all prime numbers. So I'm going to circle all the prime numbers, and I'll list them below. So I have 2 times 3. Notice there's another 2 here, so I'm going to bring that down real quick, and I'm going to put it next to the 2 times. So there are 2 2's being multiplied within this list to get to 36. There's also 2 3's, so I'm going to change colors again. And I have 2 3's being multiplied together in this list. 3 times 3 also. Now I want to simplify this list a little bit further. Since I have 2 2's being multiplied together and 2 3's being multiplied together, I'm going to clean it up. Well, 2 times itself, or 2 2's being multiplied together, that's the same as 2 to the second power. Times, in this case, 3 times 3 being multiplied together, or 3 times itself, well, that's the same as 3 to the second power. So the prime factorization of 36 would be 2 to the second power times 3 to the second power. And now I can box all this information up. Let's take a look at another problem. So this time, we're looking at the value 56. And I know that 7 times 8 will get me to 56. 7 is a prime number, so I'm going to circle it. But I can break 8 down further into 2 times 4. Now 2 is a prime number, so I'm going to circle that value. But 4 can be broken down further into 2 times 2. Now I have 2 prime numbers here which I can circle. And I've run out of values in this tree. So I'm going to list all of the circled values below. I'm going to just change colors here. So the list here would be 7 times 2 times 2 times 2. And now I want to simplify this. I want to clean it up some. So I have 7 times 2, but there are 1, 2, 3 2's here. So that's 2 to the third power. And then finally what I'm going to do is I'm going to rewrite this with the smallest values first. So I have 2 to the third power times 7. And I can box that up. I want to just make a note here. Take a look. If you're paying attention, you probably noticed that I switched the 2 and the 7 around. So when working with prime factorization, typically what happens is you list the prime numbers in order from least to greatest. In this case, since 2 is smaller than 7, you would reorder them with the 2's coming first, followed by the 7 last. So that's typical. That's what you typically do. However, since we're dealing with multiplication only, and you can use the commutative property to move numbers around, you don't have to order them from least to greatest. But to keep the information nice and neat, easy to follow, I like to simplify my information, clean up my work, and list my prime numbers in order from least to greatest. Cool stuff. I'll see you in another video.